Okay, so now we're going to discuss about the definite and indefinite integrals. Previously, we talked about the notation for the integral being given by the integral from a to b of f of x dx. And we derived this from taking the limit as n goes to infinity of the Riemann sum. Essentially, we cut up the section of the rectangular section into infinitely small widths. Now, we want to differentiate between two types of integrals. So first one is called the definite integral. This is given above as some kind of integral with two boundaries a and b. We will not discuss about whether or not these boundaries are discontinuous for now, but for now we will take it for granted a and b are continuous points. Or we could talk about, or we could also have the indefinite integral, which is simply given by this integral without any boundaries, f of x dx. When it comes to definite or indefinite integrals, we have the same number of rules. So recall from derivatives the following differentiation rules. One, we have the power rule, which states that the derivative of x to the n is going to give us n x to the n minus 1. Now, with integrals, we have the integral from x to the n dx, which gives us a reverse of the power rule. So we have, so if we were to integrate this, integrate the result, we have nx minus 1 dx. And the way we undo this, we want to match it to this. So what we do is we have n minus 1 plus 1 divided by n minus 1 plus 1, which is matches the same as the exponent. This will go away, this will go away, and from here, these two go away. And it equals x to the n, plus some constant which we will not discuss for now. So notice that in general, when we have the integral of x to the n dx, it is always going to be 1 over n plus 1, x to the n plus 1, and we have some constant which we have to include for parameter purposes. Now, let us talk about then another derivative, sine of x, which equals cosine of x. So if we were just to simply integrate cosine of x dx, we have sine of x. That's one equation. Now, what if we were to differentiate cosine? Well, differentiating cosine is the same as taking this but turning it into negative sine of x. So if we were just to simply integrate sine of x dx, we would return negative cosine of x plus c. Plus c. So these are just a few example problems that we have, or example of using the indefinite integral. To use the definite integral, we have to first integrate, and then we have to plug in boundaries. So plug in boundaries. And in general, it follows top minus bottom, so as to speak. So that in general, the integral from a to b f of x dx is equal to the integrated part of f plug in b minus the integrated part of f plug in a. And from here, this also takes on a fancy name. It is called the fundamental theorem of calculus. In the next video, we're going to integrate all of these concepts together and we'll do some example problems. I'll see you next time.